absolutely love, but the next part is a probability one, and the probability one does cause you, probability in extension 2 is a problem, a big problem. But here, at least, they've given you a little bit of a hint. So, a game's being played. Look, I'll let you read that. But basically, we need to work out what this W is. Now, the problem that I had with that straight away was that W appeared in 2 places. That's worrying. Normally, we just get an expression for W, but here we don't have one of those. So let's talk about what W actually means. W is the probability that the first person wins this particular game. Well, I'm the first person. There's N cards. One of them has my name on it. The probability of me winning on my first turn is simply 1 on N. Now, you'll notice that the question has already given us what 1 on N is, which is P. Okay, so we're going to use that, obviously. They've also given us this Q, but we'll come back to that later. Of course, I don't have to win on the first turn. I can win on the second turn. If I win on the second turn, so this is an or, I can win on the first turn or the second turn. If I win on the second turn, then everybody has to lose. Losing, the probability of losing is N minus 1 on N, which is conveniently 1 minus 1 on N. Okay. That, except every person has to lose, which is N people. And then it comes back to my turn again and I win. Yay. But you don't have to win on the second turn, you can win on the third turn. Well, if you win on the third turn, everybody has to lose twice, which is that one again. And of course, then I win. And so on and so forth. Right, so we get all of these ones all the way across there. Now I'm going to replace that with P's and Q's everywhere, just to give you a bit of a better idea. So you get P plus Q to the power of N times P plus Q to the power of 2N times P plus on and on and on and on. Now that goes on forever. That's an infinitely long series. Now, infinitely long series, that's a GP, of course. Every term is being multiplied by Qn. So we've got a first term that is P, we've got a rate that is Q to the power of N, and the number of terms is infinite. Now, if there are an infinite number of terms, then the sum of those infinite terms is going to be equal to the first term divided by 1 minus r. I know that for sure in this case because there is no limit. The other thing you have to check is, of course, the absolute value of r has to be less than 1, but of course, Q to the power of N, Q is a probability, so it's between 0 and 1, and N is an integer power, so we're okay. So we keep going with that one there, and so we get W is equal to, and this should be fairly straightforward, P over 1 minus Q to the power of N. Use my incredible abilities of mathematics to rearrange that and end up with exactly what they asked me for. So that progression there, understanding that and how to get it, and this whole idea of an infinite sum is really important. Keep in mind it's worth 1 mark. Okay, we're definitely at the back end of a test when you have to find the probability and then translate that into an infinitely long GP. But 1 mark it is. The next mark is not necessarily more difficult, but can be a little bit confusing. They give you the big hint here. Use part B. So let m be a positive integer, where Wm be the probability that A1 wins in no more than m attempts. So if m was 5, he'd win in 1, 2, 3, 4, or 5. Oh, couldn't see my fingers. So we're talking about then not an infinite sum that we had before, but a fixed sum. So let's talk about what that is. Well, let's say that m is not 1, because that's a little bit restrictive for us. Let's say that it's more than 1. So you could get the first one again. Then everybody could lose, and you could get it on the second one, right? So we know where that is. And the third one. Or, now here's a bit of a gap. What's the last one they can do? Well, everybody can lose m minus 1 times. And then I win. So I've won at this point here, and it's important that you remember that, sorry, should be m minus 1. It's important to remember that I have m goes, which means everybody has to lose m minus 1 times. Hence, yes, this is me having 1 go, me having 2 goes, but everybody's lost once. Me having 3 goes, but everybody's lost twice. So the same thing here. That is definitely a GP. It's not an infinitely long one, but of course I know the sum of a GP. to the nth term is a outside of 1 minus r to the n over 1 minus r. In this case, a is still p. The rate is still q to the power of n. But this time I have m minus 1 is my last one here. So I've got 1, 2, 3, right? 1 more than the power. So that power is m minus 1. So it's going to be m, which is nice for us. And so w to the power, wm rather, is equal to p bracket 1 minus q to the n m over 1 minus q to the n. Now, it's really important that you can establish that. Obviously, without being able to establish that, there was no use going on there. Okay, that's twice now we've used the sum of a series, one of them for a limited amount and one of them for an infinite amount. So we've got to be, keeping our eye out for there. But anytime you have these sorts of things where we're constantly adding something, you really got to keep your eye out for those. Anyway, the next part asks us to evaluate this. It says that Wm over W is almost equal to 1 minus e to the negative m. Now, I'm not going to lie to you, when I saw that, I thought that looks reasonably impossible. However, we do have the result from our first question. And there are lots of e's there. Okay? You can see it's not superbly similar in terms of where we get them from. Plus there's 2 here and only 1 here. Okay? The first bit is this. Use part B to show that if n is large enough. Now, if n is large enough sort of sparks something off with me. If you have a look at the thing that it's given, we're given that e to the power of negative n over n minus 1 is less than 1 minus 1 on n. Now, that is q. Okay, really important that we identified that early, but that is q. Okay, it even shows it to you, right? It even says it right there. So we've got a link straight away, and there's a few q's in here, but it then is less than e to the negative 1. Now, as n approaches infinity, it's important you understand that n over n minus 1 approaches 1. Because the minus 1 has almost no effect, and we get infinity on infinity, and we get 1. Which means that e to the power of negative n over n minus 1 approaches e to the power of negative 1. Now, this is very close to something called the pinch theory. Now, I could be wrong there, but I'm pretty sure it's called the pinch theory. That is, I'm approaching 2 things. This one happens to be fixed, but this one here. And I'm approaching in between those. If I can show that these 2 approach the same thing, then obviously this that's in the middle must also approach the same thing. If you think about it like this, okay, I have the value x over here, I have the value of y over here, and I have something else that I don't know, a for instance. If I can show that those 2 things are in between each other, but I can show that x approaches y, or that x and y approach the same thing, then a must also approach that same thing, because it's in between them. Okay? If that doesn't quite make sense to you, that's okay. You can just sort of go with me on that one. But I think it's really very, very important, obviously for completing this question, that you understand at least this bit. Okay? So when n is very large, 1 minus 1 on n to the power of n actually approaches e to the negative 1. Right, so once that's established, then we're actually pretty good here. First of all, we better get an expression for Wm over W, which shouldn't take us too long. Let's go to a fresh piece of paper. Cool. So Wm over W, and we'll just use the geometric series definitions for both of those. So we've got P outside of 1 minus Q to the power of Nm over 1 minus Q to the power of M, divided by, now W we found was the infinite sum, so the infinite sum was P over 1 minus Q to the power of N, not M here, sorry. Now, that does a lot of cancelling, which is awesome, and so we get 1 minus Q to the power of Nm. Now that is so close to what we were talking about. Okay, we were talking about Q to the N. So, right, this is the fact that we know. We know that 1 minus 1 on n to the power of n is going to get really close to e to the power of negative 1. well, if I can make this look like that, then we should be okay. So let's try it. So that's q to the power of n approaches e to the negative 1. Okay? Or we can pretty much, actually, I did this a very long way, but it turns out you can actually do this really, really easily, can't you? So if q to the n approaches that, well then Wm over W must approach 1 minus e to the negative 1 m, or 1 minus e to the negative m as required. Guys, those sorts of questions are not simple, but we're talking about a hefty amount of marks. That's 6 marks, but these are 6 of the last marks. Okay, you got to be really concentrating on the topics that I've already told you about, but having these ideas, getting it that these sort of questions are not mathematically super difficult. Okay, there was some integral of 1 on x here, there was some geometric sums. Like the maths itself isn't difficult. What's difficult is making those connections. The more of these sorts of questions you see, the better you'll be. But you have to decide how worthwhile it is to strive for these marks. Okay? Good luck with your study, guys. Keep it going. Bye.